in this illustration, we intend to simulate the water drop impact process in the Abaqus software. As you observe in the picture, the water and water drop are in the Eulerian part. In this question, both water and water drop are influenced by the effect of the gravity of Earth. The water drop impacts the surface of water. In these pictures, the water drop impact, having been simulated in the Abaqus software, can be observed. I will enter the Abaqus software for simulation. I will click on Create Part. I intend to create a geometric shape of Eulerian part. Here I will select 3D, Eulerian, and then Extruded Solid. Enter approximate size equal to 0.2 and continue. I will draw a square. Enter each edge of that equal to 0.04 meters. Done. Enter its depth equal to 0.035 meters and OK. I will click on Create Part. I intend to create a geometric shape of water. Here I'll select 3D, Deformable, Solid, and Extrusion and continue. I'll draw a square and enter the length of each edge equal to 0.04 meters. Done. Enter the depth equal to 0.015 meters and OK. I'll click on Create Part. Here I intend to create geometric shape of water drop. Here I'll select 3D, Deformable, Solid, and Revolution. Enter approximate size equal to 0.1 and continue. I will draw a semicircle. Enter its radius equal to 3 millimeters. Done. Enter the angle of rotation equal to 360 degrees and OK. In the next step, I will enter property module. Click on Create Material. I intend to define the properties of water. I will click on General menu, then on Density. The density of water is equal to 1000 kg per cubic meter. I will click on Mechanical menu, then on EOS, or the same equation of state. Here select USUP. C0 is the sound speed in the water, and the sound speed in water is equal to 1450 meters per second. I will enter these two parameters equal to 0. In the next step, I will enter Mechanical menu and select Viscosity. The dynamic viscosity of water is equal to 0.001 Pascal second. I will click on Create section. Here select Solid and Eulerian, continue. Select the water material and OK. I will click on Assign section. As you observe, the Eulerian part was selected automatically. I will click on OK. In the next step, I'll enter Assembly module. Click on Create Instance. Enter the water and Eulerian parts into the Assembly section and OK. I will click on Translate Instance, select the water, done. First select this point, then this one, and OK. In the next step, I'll enter water drop into the assembly section, and OK. Click on Translate Instance, select water drop, done. First select this point, then this one, and OK. I will click on Translate Instance, select water drop, done, and move that as much as 3 millimeters upwards. In the next step, I'll click on Translate Instance, select Water Drop, done, and move that as much as 17 millimeters to the right side. I will click on Translate Instance, select Water Drop, done, and move that as much as 8 millimeters upwards. In the next step, I'll click on Rotate Instance. Select the whole of the model, done. First, select this point, then this one, enter the angle of rotation equal to 90 degrees, and OK. I will enter Step module. Click on Create Step. Here select Dynamic, Explicit, and Continue. I will enter time period equal to 0.25 seconds and OK. I will click on Field Output Manager, Edit. Here enter the number of outputs equal to 100 and OK. In the next step, I'll enter Mesh module. Click on Seed Part and enter approximate global size equal to 0.5 millimeters and OK. Then I will click on Mesh Part and Yes. I will enter Load module. Click on Create Boundary Condition. Select Velocity, Angular Velocity, and Continue. I will select this surface and this one. Done, and close the boundary condition of V1 for them. I will click on Create Boundary Condition again, select Velocity, Angular Velocity, and Continue. I will select this surface and this one, and close the boundary condition of V3 for them. I will click on Create Boundary Condition, Continue, select the bottom of the model, done, and close the boundary condition of V2 for it. In the next step, I click on Create Load. Here select Step 1, then Gravity, and Continue. I will enter the gravity acceleration equal to negative 9.81 meters per squared second. Click on this arrow and select the Eulerian part. In the next step, I'll click on Tools menu, select Discrete Field, then select Volume Fraction tool, select Eulerian part, then Water part, OK and OK. Actually, by doing so, the primary place of water will be defined. In the next step, I'll click on Tools menu, select Discrete Field, then Volume Fraction tool, select Eulerian part, then Water Drop, OK and OK. I click on Create Predefined Field. Here select Material, Assignment and Continue. I'll select the Eulerian part. Here I'll select Discrete Fields, then Discrete Field 1. I'll right click in the region box, select Edit Region, select Eulerian part, done, and OK. Here I'll right click, select Add Row option, then select Discrete Field 2, then right click again, select Edit Region option, select Set 5, continue, OK. Here I'll save the model. In the next step, I'll enter assembly module. Here, I'll delete two parts, water and water drop from the model. To do so, I'll click on Suppress option. Actually, we will not need the two parts, water and water drop, any longer. If you return to the property module, you will observe that no section has been defined for these two parts. Also, in the mesh module, the two parts, water and water drop, have not been meshed. I will enter Job module and click on Create a Job. The analysis was done successfully, so I will click on Result. Here I will click on Activate, Deactivate, View Cut. Then here select EVF Void. In this manner, void space will be deleted from the model and only the water will be displayed. Here I will click on Animate. Here I have searched the water drop impact phrase in Google, and here you can observe their respective pictures. As you observe, the results obtained from the Abaqus software are very close to these pictures in the internet. Here the red color you observe indicates void, and the blue color marks water. Actually, water has been displayed with blue, while the void has been shown with red color.